Good evening, everyone. So, previous class we learnt about working with custom hooks. So, in React hooks, we are learning about custom hooks, how to handle them. After understanding custom hooks, today we will see other React built-in hooks. So, what are the React's built-in hooks and how to use them? Different types of hooks. Means already React community along with React library, they provide ready-made hooks. So what we can do is we can use them for different purpose. Last session we learnt about how to create custom hooks, rules of hooks and all we design. Now built-in hooks, some already we learnt, and what we learnt step by step, we will give one option. One hook is use state. Use state is a hook. What is its purpose? So it configures a local state for a component. Local state for component it will do. But what is the problem of local state is it is available only for that component. Generally in interviews what they ask is then how I can use the data of one component in another. That means how we can transport data from one component to another. That is another point. So first, what is use state is it configures a local state for component. It configures a local state for component. And what is the nature of this local state? Local state is available for component across requests. Local state is available for component across requests. And what is the limitation is data stored in local state is not accessible to other components. It is not accessible to other components. That is the concept of state. Already we are using this, but few points technically we need to note about this. We can configure a state and the state can store some data and the data you can access only within the component. Anywhere you can access within the component. It is not accessible to other component. Right. So when we are dealing with components here, one more concept about the component is how we can access across and use them. I will show you another point about it. Syntax, you know how you define constant. We need a getter and we need a setter and is equal to use state, and here you can store any data, any type of data you can store. You can initialize any type of data, and already I given all questions related to this, why you need state and why you initialize using a const, why not var let. Remember, I given all those points, And I told you in interview, they ask like, if it is const, how I can modify? Because const cannot assign. How a const can have a setter? Const will not allow to set a value. Then how const can have a setter? Reinitialize. When you reinitialize, you can set a value. That means you will not assign. You will initialize. Anytime you can initialize the value into the memory. That is the reason. And why const? Because state must be initialized. Without initializing the state, you cannot use the state. Initialization of state is mandatory. You cannot declare or you cannot assign the states. State initialization is compulsory. That's the reason if I use var or let, what is problem? You may skip initialization. You can assign or you can shadow others. So you know shadowing also, na? That should not be possible. That's the reason we configure as a constant. No need of any example. All these days we are learning so many examples. So what we do by using setter, we can send a new value. We can set a new value into that. All these days we use it so many examples, so no need of any example of state again. First, we will see what are the components that we already learned, right? So means hooks. Second, one more hook we learned, useRef. We learned this hook also. What is its purpose? We can create a reference memory and we can store value in the reference memory so that it is intended to use in the process instead of using in output. You want some values and functions to use inside the memory, means inside the process. It is not meant for output. Then what you have to do? You can create a reference memory. Already we done that using thread option and all, right? So what is useRef? It creates a reference memory. It can store value or function in memory. So it is intended to use, it is intended to use, where to use. So use in the process. It is intended to use in the process instead of using in presentation. It is intended to use in the process instead of using in presentation. Already we learned and how to configure that. For example, let some thread is equal to useRef and you can keep it default as what? Null. And the thread uses current. Into that you can add a value or a function. You can assign a value or function into that thread current. You can access and use by using thread current. That is use reference. So these two we used. One is state, another one is reference. These are native of React. React means along with React library they come. They are not additional. What about useFormic? useFormic is not a React related built-in hook. It is related to some other third parties. So React internally have this. So those we are going to see first. Another important, we have learnt useEffect. What it is? useEffect is used to define actions to perform at the time of mounting and unmount. But unmount we haven't seen. So mounting means after the creation, after the creation. So we have to submit. That means we have to, after the creation of component, the component have to load. When component loads, we want some action to perform, right? So how do we deal with that? So here, already we know useEffect. It defines actions to perform at the time of mount and unmount. Actions to perform at the time of mount and unmount. And one more rule we learned actually, every component mounts only once. Every component mounts only once. If you want to mount again, so it uses dependencies that specify that specify that specify when a component have to mount again. It uses dependencies that specify when a component have to mount again. Already we learned these hooks. I am not explaining again because already we done, right? And not one example, every example we were using this. So I will not waste time in repeating these again. So it's done. One new thing is how to handle unmount. So unmount is actually how to configure. So we have a syntax, how to define useEffect. useEffect uses a function and dependencies. Actually, here we define actions on mount, and after that it uses a return. It uses a return. This return is used to define actions on unmount. So it defines actions on unmount. That is actually mount and unmount. That is the concept of mount and unmount, how it mounts and unmounts. All these days we are not writing. Actually, last what it have dependency. You have dependency because it is an array. There can be multiple dependencies there. Multiple dependencies. So that is effect. Now, generally, in JavaScript, you learned what is the concept of return in a function. Basic JavaScript, already you know the concept of return. For example, because that is the mount option here. So here I will share one concept example here. In JavaScript, already you know about functions. What is the point is, generally in any programming language, you are having a function and a function name, and we have, so a function is having a return. So return and some value or function it has to return. Now, already in JavaScript, you know what is the purpose of return in a function. So generally, what majority of learning people think about is it returns a value. So a function with a return is returning a value. But how return statement can return a value? It's a jump statement. Return is a jump statement. No? Break, return, continue. These are all what kind of statements? Jump statements. So how jump statement returns value? How a jump statement can return value? Jump statement is to terminate, na? Then why it is returning a value? Actually, that is basic JavaScript thing, you know. Generally, what happens is in JavaScript, not only JavaScript, anywhere, you defined a function and with a function name, and we have a block for the function. So, what is the meaning of this syntax? What is this block? Start, and this is what? End, stop. So, what happens is a memory is allocated for a function. A memory is allocated for a function, and the memory have a name. That means by that name, memory is allocated. After memory is allocated, so it starts the actions defined inside that memory. After reaching the end, the memory allocated is destroyed. That's done. That means the memory allocated for a function, and the actions are performed in the memory, and after that the memory ends. That means the memory that is allocated for function is no longer available. It's done, deleted. It's deleted. This nature is called as void. This nature is called as void. What does void means? Void means it discards the return of any function. That means if a function is having some memory, it discards that memory. Whatever memory is allocated for the function, it is destroyed. It is destroyed. That's what actually the concept here. Now what we are doing is in this function here, I am using a return keyword. Means I am using a return statement, return. And suppose I am using some value. That means what you are doing before this memory is allocated, after memory allocated, some actions are performed. After actions performed, before returning to the end, you are using a return. That means what you are saying, I am terminating this function before it ends. Before it ends, you are terminating a function. Do you know what will happen? The memory allocated for function is still alive. It's not deleted. Why it is not deleted? Because you haven't made it end. That means you haven't taken the control to the end. You stopped it in between. What is the purpose of return? It terminates the function. Anything after return is not reachable to compiler. Compiler cannot reach. That means in interviews they ask like, okay, you learned like this, huh? A function means it returns a value. Can a void function use return keyword? Yes, a void function also can have a return keyword. A void function also can have a return keyword. That means return keywords purpose is not returning value. Even a void function also can have return keyword. Why you need void? I will tell you here. Point is C. That means, for example, because you need to understand mount means you need to know all these things basics. So usually we have a script. So we have a function. This is print and it is a void function. Document dot write line 1. So I'll just put a break. Okay. And I'm having line 2, line 3, line 4, line 5, something like this. I have 2, 3, 4, 5, 6 like this. Now after 4, I am using return. This is a void function. Void function can have a return. That means what does it means? After statement line 4, it will stop. It terminates. Anything you return after that, line 5, line 6 are not reachable. We call it as unreachable code. Any code that you return after the return keyword is not reachable to compiler. So compiler is not going to execute these two lines. So what it is going to do, it is going to execute only this. That means we will call the function which one? Print. And it is going to print only this. Line 1 to line 4. Now why you are writing the lines and why you are not reaching there? That means why you return line 5 and line 6 and why you are not reaching. That means even a void function also can have return. Because return is not for returning values. Return is for terminate. Why you designed this? Because actually in real world projects, we call these as stubs. Stubs means what? Up to 4 I need to test. 5 and 6 are under construction, later need to be implemented. I don't want my compiler to reach there. Then what we do? We put a return. So it will stop there. After 5 is completed, I will move this return here. Then it will print the fifth one also. That means this is basic actually. What return is going to do here now? See, what return is going to do? We have a memory. This is the memory allocated for whom? Name. What happens now is you are using return and you are using some value. What does it means is first memory is allocated. After memory is allocated, the memory doesn't end. Why memory doesn't end? Because it is unable to reach the end. Before reaching the end, what you have given, you given return. Then what it will do is it keeps the memory alive. And in that memory, it can store this value. Value or function, anything, it can store that value inside that memory. That means what is the nature of a void function? Memory allocated, actions performed, and memory destroyed. But in between, you are adding a return keyword, means what happens? Memory allocated, actions performed, and memory is not erased. Memory is still alive. Why? Because you are not reaching end. You are stopping there. Before it reaches end, you are stopping. That means memory is still available. In that memory, you can store the data. You can store the data. That means whatever the value or function you give here. Remember, it can be a value or a function. It a value or function. It is stored under this reference name. That means now this function works as two. It will work as a function and it will work as a variable. Variable where you can store the data. That means the result, the value can be stored under this reference. Under this reference. What is difference between void and this return? Void destroys because it reaches here. Return will not destroy because it cannot reach here. That means memory is still available. memory still available. That means you see what we are doing now. Suppose I am writing a function. So I am writing a function some addition. In that we have a and b, two values are present. Just addition is one function. What we need to do is we need to calculate the result of a plus b, and we need to store that in some memory, and we need to use it here. Print. In print, I want to display the result. Document dot write addition is equal to I want to print the result. Now, generally, I have to calculate a plus b, and I want to use that in another function. Usually, what happens, JavaScript. So here you declared a variable c, a plus b. What will happen? This c have a function scope. Function scope means what? So that means it is not accessible outside the function. Do you know why? Just now I explained. Because the memory is erased. After the function is completed, memory is erased for that function. Then the C is no longer available. Then how you will use it? Okay, now you will say that I will declare a global variable. If you declare a global variable, you can access it in another function. That means you are using two memories now. One memory for function, another memory for storing its results. Why? You can use the function memory for storing the results. You can use the function memory for storing the results. How you can do that? Simply, what you can do, you can put a return. When you put a return, what will happen? It will perform a plus b. After that, it will use a return which will not allow to go here. That means the memory allocated for addition is still available. In that memory, this result will be stored. That means now obviously it is in the script area. That means it is a global variable only now. It is a global. Addition is a global. That means what you can do, you can access that addition here, and into that you can pass the value. That means what it will do, it will take 30, 50, it will perform addition on that. That means it is going to take 30, 50, it will perform addition, it will store the result here. Because you are not reaching here, so memory is not erased. Memory is still available so that you can access and use. That means the result of this can be stored in the memory. So return is not returning value. Return is avoiding the erasing of memory. Return is actually avoiding erasing of memory for a function so that the function memory is still alive. This is not a good practice every time. Why? Because if memory is still available for the function, then it uses more memory. It is risk for memory because so many functions, memories are loaded in that. Memory overload will happen. That's the reason we don't use this every time. So without this also we can achieve that. How we can declare a global variable. Why you are declaring a variable not required. You can use the same function memory for handling the result returned by the functions. This is what generally we do. That means when I call print, that means it is going to perform that and display. That means it is going to display. Right? That means you don't need another global variable because now addition itself works as a variable. That is actual meaning of return. Return means it will terminate before it ends. And if it terminates before it ends, that means the memory is still available so that we can store it. We can use it. And you know that return can return a value or it can return even a function. So it can return a function. That means now in the memory of addition, we have a function. What is that function? In the memory of this addition, we have a function. And this function can do some functionality. It can do some functionality. So suppose I'm accessing just return here a plus b. That means what it is doing, addition is not directly now having. Addition is having a function. Addition is having a function. So we are calling that function. Into that we are passing the value. That means 40, some 50 like this. And in that there is a function. We have to call, actually this will not return the result. Why it is not returning the result? Because it is returning a function. And how do we call a function which doesn't have a name? You call a function that doesn't have a name by using a mechanism. What is that? IIFE. Immediately invoke function expression. Immediately invoke function expression, which is nothing but empty parenthesis. Empty parenthesis. That means it is immediately invoking function expression. That means here beside it, I will put a parenthesis. Right? I will put a parenthesis here. This is the function which returns the functionality. That means actually it is returning the value. That means a function can return a function. Right? So, or a function can return a value. Return a value. So what is the intention of this? Intention is keep the memory alive. So here, that is general JavaScript thing actually. This is all general basic of JavaScript. Now that is what here return is doing. What return is doing? It is returning a function. What this return function will do before it ends, that means before this component ends, it will erase the memory. Actually, it is going to erase the memory. While erasing, you want any functionality, you write. Understood? You want any functionality, you can write. That means now that is not erased, it is kept alive. You see, you have a function. This function is using which keyword? Return. And return is returning a function. What does this means? That means it will perform this functionality and it will store that in the memory. It will store that in the memory. That means even component ends, the memory will be available. Memory will be available. But our next challenge is how to access the memory and use it. How we can access the memory and use it. For that, other techniques you will learn, you will understand. But how to write a unmount phase for component? To write unmount phase for component, useEffects needs a return. Needs a return. Through return, you can write unmount. Means when it is unmounting, it will perform the functionality. Now the question is, here the question is, when a component will unmount. So when a component will unmount, that is the question. When a component will mount, whenever you call it, it will mount. Whenever you call component, it will mount. But when a component will unmount, so a component unmounts when you request another component. When you request another component. A component will unmount when you request another component. When you are requesting another component, this component will unmount and another component will mount. Another component is going to mount. So until or unless you close the application or you request another component, the component will not unmount. So when a component will unmount, when you request another application. So or what is another one? Or when you close the application. When you close the application. So when you close the application or when you access another component, then this component is going to unmount. So let's see the process here. So I will show one example here. That is general JavaScript. Actually, we will add a new component. So mount demo. Okay. So mount demo.jsx. So export function mount demo. Okay. And here I am designing a simple interface like, yeah. So we have two buttons. Let me keep two buttons. So one button is login, another button is register. Okay. We have two buttons. So class btn and btn primary. Okay. Fine. So this is another one, btn and btn, some warning. So below this, we will keep a container margin of 4, and I am creating a state constant. So one is component and a set component. And usually this is use state and it is empty. Nothing is defined here. So what I will do now, we are having two more components. Here itself, I will create another component called login. And what it returns a simple user login, something like this. I'm just giving a message. Huh? Now, similarly, we have another component. Actually, you can create in separate file and you can bring it here. You can import them. Initially, I'm just keeping all in one place so that you can see register and it returns what it is going to return. It is going to return some heading. So register user. Okay. So this is some user login. Fine. This is two components we have, login and register. Now what should happen when user clicks on login? Login component should load. And user register component should load. So what we will do, function handle login click. On login click, set component. Into that, we will pass a login component. That means directly that component is rendered. That component is sent into state. Okay, another function. So handle register click. And register click should set component. Which component? Register component you need to load. Directly load that components. And where to show the components that are requested? Here. That means here we want to display those components. I am directly showing the component here. Component can have all the screen, login screen and everything. Now we have button on click. On click is what? Handle register click. Now this is login click. Huh? This is handle login click. Okay. And what is this one? On click. On click handle register click. This is handle, right? Handle register click. And this is handle login click. Fine. Now what we do, you see the design. I will keep this in the startup. So it should start with mount demo. Mount demo. And in the mount demo, you can see it is having these buttons. Okay. Now I click on login, then login component will mount here. And when I click on register, register component will mount. That means we are requesting a new component. So another component we are displaying. We can access those components and we can render those components here. It's not just heading. Anything you can have in that component, it will come. Login and register. So that means everything is defined. Everything is defined inside this. Now, what is the concept is, let's go to login. And here we will write useEffect. That means we have a mount for login. Okay. And what useEffect have to do? useEffect have to perform. Here I will put a console log, console.log. I will put an option as login component mounted. Okay. Now I will write a return. What this return have to do? So console.log, I will put a message login component what? Unmounted. That is the option we are defining. Same thing, I will write use effect for register also. And here register component mounted and register component unmounted. Register component unmounted. Now, what we will do is we will go to index and remove this strict mode, because strict mode is going to compile two times, one for build, another for deploying. So we will remove this strict mode, because if you don't remove the strict mode, it is going to execute two times, one for compile, another for run, right? It is going to handle two times, build and run. Two options will work, and we don't want that two times. Then your messages will be confusing. You will see every action is performed two times, right? So I will remove that strict mode. Okay. Now see the console here. In the console, you can observe in the console currently empty. I click on login. So what functionality will happen? Login will mount. Login will mount. When I click login, login component mounted. Okay, good. When it will unmount? When you change another component. That means I requested register. Now first what will happen? Login will unmount. After that register will mount. Register will mount. You see, when I click register, login unmounted, then register mounted. Two activities performed. When I click again login, what will happen? Register will unmount, then login will mount. That means it is going to mount. It is going to mount. That means usually cleaning the memory, deleting the tasks, so many other. Later I will explain a life cycle. What kind of activities we keep in unmount phase, we will learn about that. We will see. So usually when a component will mount when you request, when a component will unmount when you are changing. This will be very confusion if you keep the strict mode on. That means if you keep the strict mode on, see what will happen. When you keep the strict mode on and you click on this button, you click on login, then you can see login mounted, login unmounted, again login mounted. Actually what happened, first time it built, while building it executed. After that it is running. At runtime again executed. But finally what happened is mount. So first time it is building, means it is testing. After testing, it is running, right? I don't want to test and run. I just want to run. That is the reason you better remove this. Then you will understand it more clearly, right? That means now what happens here? You click on login, then login is mounted. You click on register, the login unmounted, register is mounted. That is how the options work. That is mount and unmount. It is very important in interviews in many, because in previous versions of React, there is a separate function for unmount. That means usually we have two functions, one function for mount, another function for unmount. But in React 17x 18 versions, they have moved from that technique that you generally see in class. Later I will show you in class. Now we have another option. What is it? In useEffect itself, we have both mount and unmount. If anybody asks you like what is useEffect, you should not say mount, you should say both mount and unmount. useEffect is a hook used to control actions on both mount and unmount, right? That's important. So how you how to define unmount for component? Answer for this is by configuring return function, by configuring return function for useEffect hook. By configuring return function for useEffect hook, you can do that. Right. So how do we do that? So syntactically, already I given syntax, but just roughly useEffect, and it uses a function with the dependencies. In this function, you need to use a return. That return performs the functionality. That is one option. This is useEffect. Already we learned, but one more additional thing is unmount. How do we define that? Example I will give here. Mount demo.jsx. Let me copy this. Just for understanding sake, I kept all components in one file. Is it possible to do that? Yes. Right. But what you will miss is you cannot reuse the component anywhere else. You can use only in this component location. Sometimes we do. Sometimes we want a component in such a way that it should be used inside this component only, not accessible outside. Then what you can do, you can define in this way. Of course, you can import and use it externally also. You learned now in module system, we can import a function and we can use the function from any place. So you can create a separate file and you can try that. But this is just, and one important note is remove react.strict mode from index.js to test mount and unmount. React strict mode. To test mount and unmount. So this is how to configure useEffect, right? And dependencies, last session I showed you. That means when a component will mount again, whenever URL changed, it will mount again. Later, so many other examples also you will see how to write the dependencies. In last session, we created one. That means we created a custom hook called fetch data, and what it is doing, it is mounting again. When it is mounting again, when it is going to change the URL. Like that, we can put a lot of dependencies later, you will see in different example. Next, important. Now, another concept here is after understanding useState, useRef, and useEffect, we have another hook, that is useContext. useContext is another hook. useContext is another hook. Actually, in web applications, context means context memory. Context is context memory. I already told you in hooks, I will tell you there is a separate life cycle also. In life cycle, we are going to learn. So generally, what kind of activities you put in unmount? It is a common sense about software developer. Every developer knows that what he need to keep while destroying. What he will keep in destroying, I finished using, then what kind of activities we keep inside? At the time of destroying, what you keep? You will create a variable to store data, na? No. What you will do? You will clean up the memories. You will disconnect the connection with APIs if you have any connected ones. You will reset all the values, na? Usually, what kind of activities we do in unmount? Erasing the memory, reset the memory, disconnecting the connections if we have. All such activities we do in which phase? Unmount phase, right? We will see several example also now. What is context? This is very, very important, right? Actually, suppose, let's see one concept. I will add a new one. So context demo. So context demo.jsx. Okay. So export function. So context demo. We have written. So return is having some presentation. Yeah. So we have a class container fluid. And here I will just keep, this is actually parent. Just I am giving parent component. Let's keep the component here in the startup context demo, and it is the parent. It is showing the parent here. It is displaying the parent. Fine. Now what we will do is we will create a child. So actually in the context, this is parent. We have configured a state. Some MSG set MSG is equal to what? useState. This is like some welcome. Something is there. And what we want here is we are creating another component, export function, child component. And what we want this child component written, a heading. This is actually child component. And we want this child component to use inside the parent. We want the child component to use inside the parent. So that means here I will access child component. Inside the parent, child component is there. Now, the value of parent, I want to share it to child. That means the state I created for parent, I want to use for the child. Now, can this child component access this message? That means in that child component, we will put a paragraph. Here I am trying to access MSG. Is it possible? This child component is called inside parent only. Is it possible to access the state of a component by its child components? a component which is running inside, can it access parents' memory? It's not possible. State is not possible. State is for the component that you configured. It will work only for that component. It is not accessible even to the components that run inside the component. That is not possible. That means the state, use state, is a memory configured for a component and it is accessible only to that component. It is not accessible to any another component which is even running inside it. It is not accessible. Every component state is individual for that component only. It is not accessible to others. Then how you can make the data of parent accessible to child? We need to transport data from the parent to child. There are so many techniques. One important is actually we have context. Actually, in web applications, context refers to context memory. Context refers to context memory. And what is the speciality of this context memory is context memory is allocated for a component. Context memory is allocated for a component and it can be and it is accessible to components that run within within the context of parent, that run within the context of parent. So context memory is a memory. Every web applications have this memory. Every web application across every technology in the world, they use a context memory. Actually, context memory is nothing but, for example, we are having server. So just keep a simple. Suppose we are having server. Now we are having two pages. That means page 1 and we are having two web pages are present. Now you requested page 1. When you requested page 1, this page 1 loads into server. That means what happens? A memory allocated. So a memory is allocated for home page 1. Now what happens is you are moving from page 1 to page 2. Then the memory for page 1 is deleted and page 2 memory is allocated. That means can page 2 access the data of page 1? No, because it is deleted. This is what we discussed in the beginning, stateless. HTTP is a stateless protocol, right? That is the point. Now what happened is you are not moving outside page 1. In the page 1, you are accessing page 2. That means page 2 is accessed in page 1. That means what you are doing in page 1, you are accessing page 2. Here you are accessing page 2. That means not navigating outside page 1, you are bringing page 2 inside page 1. Then do you know what we can do is the memory available for page 1 can be shared with page 2. And that memory which is shareable with page 2, that memory is context memory. That means every page have a context memory. That memory can be shared only with the pages that run within the context of the page, parent page. If it is outside, it is not accessible. Once you go outside that page and go to the second page, the memory is no longer available. The context memory is a memory which is allocated for a page, and it is shared to all the pages that run within the memory of page 1. Within that memory, this memory is called context. And several traditional web applications have a context memory inbuilt available. Java, .NET, all these technologies, they have context memory internally. That means Java, .NET, other technologies, they have a context memory internally. That means you create a page, a context memory is also created. You have to just use it. But in React.js, context memory is not created. For a component, context memory is not created. We have to create a context memory if we want. Then that context memory can be shared by other components that run inside that component. That means context memory is a special memory allocated for pages. And this is not by default allocated for components. So then explicitly what we have to do, we have to create a context memory and we have to use that context memory. That means use context is not for creating context memory. So there is no use of this hook. This is useless. If there is no context, from where you will use context? So in order to use context, first you have to, in order to use context, first you have to create context. And in many technologies that is automatically created, but here we have to manually create. In React, it is not there. In React.js, every component don't have a context memory. At experience level interviews, they ask, do we have a context memory for component? First, you should know what is context memory. So React don't have context memory for components implicitly. We can explicitly create a context memory. Context memory. How we will do that? That means what is the nature of context memory? It is memory allocated for a component and it is accessible to the component that run within the context of parent. So here context is explicitly created in React. Context is explicitly created in React by using create context. By using create context method, we have to use this create context function. That means first you have to create a context. We have to create a context. So how to create a context? So we have to create, suppose context name is equal to create context. And in that you can keep any data you want later. It is null. Null means dynamically you can store any data. So first you have to create a context. Now context memory is created. In that memory you can store any data. In that memory you can store any data. So, but here another point is that actually this is the context name. Now what should happen is, so context requires a scope. Context requires a scope. Context requires a scope. Actually, context requires a scope with the provider. With provider. Last session we discussed that we need a provider. We need a provider, right? Service requires a consumer, provider, injectors, right? What is the job of provider? Provider is responsible for locating the value in the memory. Is looking for the value in the memory. That is the job of a provider. So what we have to do is, see here, one important point is there. For example, this is the parent. Now parent is having a context memory. Parent is having a context memory. This context memory of parent can be shared with the child. So for example, we are having here child 1, child 1, and we are having child 2. And remember, outside that context also, there can be child 3, child 3. Now the data of parent is accessible only to these two. It is not accessible to child 3. If it has to be accessible, it should be inside its scope. It should be inside the scope. That means every context memory have a scope. You can limit that scope. You can say that these two childs must use, this should not. Then if any child should not use that data, then you keep it outside the context scope. It cannot access now. That means if anyone asks you an interview, will every child able to access the context? Every child is not accessing the context. Context is accessible only to the child which are inside the context scope. Inside the context scope. How you create this context scope? Actually, we create like this. We have a context name, provider is equal to the value, what data you want to provide. This is the context name. This is the context scope. So here the child components will be there. That means make sure that all the child components are inside this context. If any component you keep outside this, they cannot access. They cannot access. That is the context. So first you have to create a context. After creating the context, you have to define the scope for the context. Now, this context can be used by whom? Child components can use the context. How? By using useContext hook. That means if you don't create context, you don't have a context scope, there is no use of useContext hook. So that means child components can access and use context memory by using the hook. And what is that hook? Use context. That means how do we do? Syntactically, we create a context. That means we define here let some reference name is equal to use context and the context name. That's it. That is the context name we need to configure. Right. That is the use context. So that means now whatever data provided by this context, the data is accessible through this reference. Whatever, any type of value you can have in a context. Memory means any value. It may be primitive, non-primitive function, anything you can have in that. This is the process. So you cannot use the context directly. So, and what is the specialty is the context can be accessed at any level and use. You can access and use. Okay, you see, I am creating like this now. So it's not accessible here. So I will use here. Yeah, this is level 1 component. Okay, this is level 1. component. I'll remove all this later. Yeah. I'm accessing the level 1 component here. So level 1 component we are having. So there is another one. So we have a function. So the function is level 2 component. Okay. And this is level 2 component. This level 2 is in level 1. In level 1, we are accessing level 2 component. In nested hierarchy, we have a parent in that level 1. In that level 1, we have a level 2. Level 2 is accessible inside level 1. Right now, we are doing this here. What we will do for this parent, I will put BG dark. So text white, padding 4. Okay, this is actually parent component. Okay. After that, level 1 component, we have a class margin 4 and padding 2, padding 4, BG suppose danger and text white we are using. This is level 2 component, level 1. In that level 1, we have level 2. It is having margin 4, padding 4, BG warning and the text dark. And this is level 2. Now what we want to do here, the data from this parent must be shared to all. The data from the parent, it should come from parent to level 1. And I should able to access this in level 2 also. Obviously, it is accessible at any level. At any level, you can access and you can use it. So let's see how. First, is the parent having a context memory? Parent is not having a context memory. So what we have to do, we have to create a context memory. LET. Suppose I given user context is equal to, what is the function? Create context. We have to use create context and initially it is what? Null. Okay, now what is the scope of context? Scope of context is parent na? That means in the parent, here we have to define what is it? User context. In this, the parent can access the level 1. So level 1, this is the level 1 component inside the context. Inside level 1, level 2 is there. Inside level 1, level 2 is there. So context is accessible for level 2 also because it is inside that context only. Okay. Now this context needs a provider. We have a context. This context needs a provider. That means we have to use a provider. Actually, it uses a value. So this is an value. How to define the value? Who is responsible for locating the value? So context dot provider. We need a provider. That means every context needs a provider. This provider is going to collect the value. What value you want? Suppose I will give some username. So this is a string, some John. Right. This is accessible to parent. Actually, we will put this message better. That means what we will do, this message is having some John. Okay. Then here value comes from where? Value comes from message. This message anyhow in the parent it is accessible. State is accessible to current component. That means current component is able to use that John. Then how it is accessible? State is not accessible to level 1 component. Then what level 1 component have to do? Where is level 1 component? This is level 1 component. It has to configure. What is it? Context is equal to what it is? Use context. Which context we have to use? User context. That means through this context, it can access this value. That means here I will put in level 2. Here I will put that value. What is it? Context. That means it is able to access that John in level 2. Level 2. Can level 1 access it? Level 1 also can access it. The context you created for parent, it is accessible to this one. That is the inside any component can access at any level, any component can access. That means it is accessible to this, it is accessible to this also, right? That means how level 1 can access that John, how level 1 can access that John. In level 1 also, what you have to do, we have to create a context. And what? Use context. What is it? User context. Now it is displayed here. That means here in level 1, here we are configuring. Yep. So this level 1 component here we have to use, what is it? Context. That means level 1 component is also using the context. It is accessible here also. Anywhere we can access and we can use it. The memory of parent can be shared to child. And I just given a plain value. You can use, suppose what we will do in the parent, we will write a function. So handle name change. Okay. We will use an event argument. That means set msg e dot target dot value. In the parent component, I will keep a text box here. Means in the parent, I will keep a text box. Input type is text. And whatever they enter on change, right? On change, it has to use handle name change. That means it will set the message. So what happens now? It is empty. And initially it is empty. Now what we need to display there? So whatever the value, by default it is John. I will remove that. I will keep it empty. So currently level 1, level 2 don't have anything. You are typing something, they are accessible to all. That means you can transport data from the parent to child. That is possible by using context, right? This is called context memory. So how do you create a context memory? By using create context. How to access and use that context memory? By using use context. So how you can transport data from parent component to child? That is possible by using what? Context. Now so many questions will be there, like how you will transfer it from child to parent. Is child context accessible to parent? No. Only parent is accessible to child. Child context is not accessible to the parent. Then we have to implement other techniques, which you will learn. Other state management techniques we have to maintain. Now we have another one. We have reducers, redux. So many are there for this state related concept. So we will see other techniques, but this is the example. What is it? Context demo.jsx. Here we are keeping this example. This is related to context, right? So once you know this, now we will see another technique. There is another technique of transporting data from one component to another. For that, we need to understand a concept called uncontrolled component. That we will see in next session. Tomorrow we will do that. Tomorrow we will understand what is uncontrolled and controlled components. Controlled components. And through that we will learn how to transport data and work with the data. That we'll see in next session. Tomorrow we'll continue. Okay. Tomorrow I will share a group of lab community. So there you can share your tasks. Okay. Tomorrow we will create one group for lab community and I will share with you. You can share your tasks there. Okay. I will check. Right. Yeah.